Hey everybody, your target for today is to be able to draw a line of best fit and write its equation. And for those of you keeping score at home, this is section 6-7. So let's get started. A line of best fit. If we have a graph here and we're plotting points, you can see the points kind of showing up as we go here. If you'll notice, these points don't lie on the same line, and that's what this says here, is that usually there's no single line that passes through all data points. If you were to collect data, these points don't mean anything, but if you were to collect data, those points could mean something. And there's not always going to be a straight line that goes through all these. If I told you to draw or asked you to draw a line that goes through all these points, it would have to be kind of bendy and bend around, and a line is straight. So there's no straight line that goes through all these points. So we want to try to find a line that best fits the data, that best models what the data is doing, and that line is called the best fitting line. And that line you would just draw that kind of shows where is it going here, what is this data doing, and there's not always one exact answer if you're just doing it from a graph here, but the best fitting line in this case could look something like this yellow line. This yellow line pretty well shows what the data is doing, and that is called the best fitting line, or the line of best fit. You can call it either one of those two things. And notice it doesn't go through all the points. It goes through some of them, but it doesn't go through all of them. And it can't, because if it did, then it wouldn't be a straight line anymore. So there are several ways to come up with this line in terms of its equation. I mean, what you do really is you just plot the data points, which we did, just kind of random data points, that whatever we have. Then we just estimate the line of best fit. When you're if you're asked to draw one, you can only estimate it. You can't get anything precise just by looking at the graph. You just kind of estimate what the line looks like. And then you find 2 points on the line. What are 2 points that are actually on the line? And then you can write an equation for the line given those 2 points. We've done that. Given 2 points, we've written an equation before, and that's essentially what you would do if you're trying to find the equation for the line of best fit. It was the exact same thing. So plot your points, estimate the line. This yellow line here isn't going to be the same for everybody, but it will look pretty close, the same no matter what who's drawing the line. Then you want to find 2 points on the line and then write an equation with those 2 points, which we've done before. So here is some data, not the same data we were working with before, but this data is mapping or plotting the data of the discus throws in the Olympics from 1908 to 1996. So in 1908, which was year 0, well, we have actually 1908, which is right here, years since 1900. 1908, it was approximately, looks like 132 or something like that. I'm not exactly sure exactly where that lies, but it's somewhere between 130 and 140, probably about 132, 133. And all this data shows all those distances from all those Olympics. Each one of these red points is a data point from those Olympics. And then the black line is the line of best fit, just a line that I drew that models the data. It doesn't go through all the points, it goes through some of them. Doesn't actually have to go through any of them, but it looks like it goes through a couple of them. And this is an approximate best fitting line. If you're just going to draw it, it doesn't really matter what that looks like as long as it resembles the data pretty closely. So we have our best fitting line right there, and we're going to write an equation for the line. And if we're going to write an equation for a line, we need to have 2 points. If we don't have 2 points, then we can't write an equation for the line. So we're going to pick 2 points that are on this line. So we are going to use the points 8, 138, 8, 138. Well, that doesn't really look like 8, 138, but I guess they're saying it's 8, 138. So this is 138. Thought that was 132 or 133, but they're saying it's 138. You can look that up. And then at 1996, because this is years after the year 1900, at 96 it was 230, which is right about here, so it's about 230. That's what they're saying. So these are the 2 points we're going to run with. We're going to run with these 2 points that are allegedly on our line of best fit, and we're going to write an equation given those 2 points. So how do we do that? We find the slope. If we want to write an equation for a line, we need to know the slope. So we're going to do that by using the slope formula, y2 minus y1 over x2 minus x1. And given the 2 points we have, we can do exactly that. So I'm going to take 230 minus 138, 230 minus 138, divided by 96 over 8. and that will give us the slope. And the approximate slope of this line is 1.05. The 92 comes from 230 minus 138. The 88 comes from 96 minus 8. 92 over 88 is approximately 1.05. And if you want to leave it as 92 over 88, that would be fine. That might pose some problems later, though. So we're going to change it to 1.05, and we'll see why here in a minute. There's our slope-intercept form. This is an equation for a line, slope-intercept form. We just found the slope. 1.05 is the slope, so we can plug that in for m, and that's what we're going to do. 1.05, here's all the work we just did. Slope-intercept form, we're going to plug in 1.05 in for m, and then we're going to plug in 8, 138 for x and y. Why are we going to plug in 8 and 138 for x and y? Because we know that 8 is an x value that's on our line, and we know that 138 is the corresponding y value that's on that line with the point 8. And then we can solve for b. We can solve for our y-intercept. So now we have a little bit of math we can do. 1.05 times 8 equals 138. If we do that, we get 8.4, because 1.05 times 8 is 8.4. So now we have 138 equals 8.4 plus b, and now we're in a position to where we can solve for b by subtracting 8.4 on both sides. So we get 129.6 is equal to b, or our y-intercept, and now we have all the information we need to write the equation. So the equation for the best fitting line that we drew is y equals 1.05, because that was our slope, x plus 129.6, because that was the y-intercept that we found by plugging in the slope we found and one of the points that we were given that was on the line, which was 8, 138. So this is our equation for the best fitting line. Nothing different than what we've done before. The only difference here is that we've added a step where now you are drawing the line of best fit and then picking 2 points and finding the equation based on that. So what this means is that in most years the winner of the discus throw was able to throw the discus farther than the previous winner. If you go back to the graph and look, the graph is going up, meaning that every single year people are getting better at the discus throw. How much better? Approximately 1.05 more meters than the year before. Correlation is exactly what this is. It's talking about a correlation. A correlation is a relationship between two variables. And in this scatter plot right here, just a bunch of points that are plotted, we notice that as we go from left to right, the data goes up, and that would mean we have a positive correlation. If the slope of the line of best fit is positive, that means there's a positive correlation. As one value increases, the other value increases as well. So this would be a positive correlation, which is also comes from a positive slope. Subsequently, a negative correlation means a negative slope. That means as one data values increase, the other data values decrease. So that would be a negative slope. So a negative correlation is a negative slope. And then we have data that could look like this and say, well, what about a line of best fit here? Data's kind of all over the place. In this case, there's no correlation. There's no line of best fit that we can draw here because the data's kind of all over the place. You don't really know where the data's going, and can be anywhere. There are points all over, and the relationship of one variable and the relationship of the other variable, or the relationship of those two things together, just doesn't make any sense. So, and that's what this would look like if you were to plot those. So there's no line of best fit that we can draw here because data's everywhere. If we ask what happens as we go to the right, we don't know exactly where the data points are going up or down. So there's no correlation. Quick review here. Types of correlation. Positive correlation is the data is increasing or it's going up as one value increases. Negative correlation is going down. It's a negative slope. And then there is no correlation, which is just data all over the place. So those are the three types of correlation, and which resembles kind of the slope, at least in terms of the positive and the negative that we've talked about before. So your target is to be able to draw a line of best fit from a graph, plotting points, draw that line, and then write its equation. Given 2 points, write its equation. You can find 2 points that are on that line, and then write the equation. And that is section 6-7.